Hello everyone, my name is Hariri. I am a lecturer from University Kebangsaan Malaysia. So I like to participate in 4th Asia Pacific meeting on near surface geoscience and engineering, which is this year conduct at Vietnam. So my topic today is about modeling of the Bouguer gravity anomalies for mineral prospection, which is paper number 18. This is list of my team. Dr. John Kayode is not available to present this paper. So on behalf of this group, myself, Hariri, will present this topic today, and the rest is my group of research that prepare all the material involved in the site data acquisition, petrographic analysis. Okay, for the introduction, our site is located in Lodging, Gua Musang, Kelantan. Is about to northern part of Peninsula Malaysia. So this is our study area, and then we mark also some sort of fault that we observe at the site and then interpreted one. Basically, the study area consists of conglomerate in Gunung Ayam, and then also ophiolite that consists of serpentinite and peridotite and schist on the western part. Okay, and then in the northeast area consists of melange. Alright, so we conduct the gravity survey, which is cover around 176 total of station survey. The study area cover about 3 km square, and then basically for the study area is quite hilly, yeah. Okay, so we conduct the survey around end of 2017 in August. We repeat 2 times because based on several factors. So until September we finish the data acquisition at the site. Next, okay, this is some sort of observation at the site. We mark 2 fault and then the set of bedding going to the northward, and then for physical observation, we noticed that this silica rock have fine grain texture, very hard, dark gray color to the brownish color, and then we believe the structure of this silica rock made few outcrop exposed to the surface. Okay, now you can see from drone photos taken on that time. So we have few outcrop there. So based on our study research study here, we try to identify connectivity of these 2 main silica rock. And then next slide, you can see different angles. So quite a hilly the research area. And then to get more view, you can click, you go to this YouTube channel from myself, Hariri Arifin. You can search silica rock in Lodging. You can see the videos, more view for this site lah. Beside that, we also conduct the petrographic analysis, which is we took 2 samples at the site, and then we conduct the petrography analysis, and we name this 2 samples as arenite quartz. The main composition come from quartz itself, 97%, and then 1 to 2% from mica, and then the rest filled by sericite, clay, and iron oxide. And then the triangle junction border can be related to changes of pressure and temperature in metamorphic process, which if we can observe under microscopic view. Next, for method of data collection, we use what we call it CG5 gravity meter and resistivity meter. So basically the target is try to cover the whole study area, which is 3 kilometers square, using these two methods. Okay, for method of data collection using this CG5, we believe that this equipment can provide a good data, and then from that we can interpret the Bouguer gravity anomaly (BGA). We use structural index SI values of 1.0 for deep-seated dike. And then for resistivity equipment, we use ABAM thermometer, 3 survey line, 2 of them were 400 meter and only 1 survey line that 800 meter straight line. And then we combine with the IP. I hope some of you may be expert in IP, can comment, can help me to interpret the data. Hopefully I can improve my work together with my team. In our survey, we use pole dipole array, try to capture the deepest part subsurface information at the survey area, because we want to know the volume of the silica rock at the lodging. And then for data analysis, we use REST to the inverse program from a host geo software to process the resistivity data and IP. And then we also use CorelDRAW to label, to interpret the result, to make sure our result and map that we produce using ArcGIS can be established. Next, basically for BGA, Bouguer gravity anomalies, we process using a few correction. Of course, as usual in gravity data, we need to settle with free air correction, terrain correction, and tidal correction to make sure that our raw gravity data can be improved before we start for interpretation. And then of course we use also Euler deconvolution techniques for quantitative process. Okay, then this is few result. I think their value that we process and record here from 54 milligal until minus 192.8 milligal. And then what we decide last time, we said that the high BGA values is can be observed in the southern part. We believe it was a deep-seated fault, and then for northern eastern boundaries, maybe the intrusion is more than 300 meter. Okay, based on this slide, we can see that it's much clearer the greater value of density in this area, maybe caused by silica rock that already exposed in two main outcrop here, very high value here, and then this one, and maybe in the eastern part that cover a little bit by alluvium. However, here we interpret because the gravity value is quite low, so maybe the alluvium here is quite thicker. Then the high BGA values is delimited by probable deep-seated fault, which is we can observe from site observation in the outcrop at the study area. And we interpret again intrusion at the some depth of greater than 300 meter based on this result. Okay, for resistivity part, remember we have 3 survey line, 2 of them 400 meter, only 1 of them 800 meter. So result line number 1 to be integrated with gravity data. So we have more than 2000 ohm meter, which is we interpret as location of silica rock. And then we believe this low resistivity value may be reflected from fault or fractured system that can separate the body of silica. And then here for IP result, I'm not really sure how to interpret now. So please someone can comment or directly email to me after this presentation uh, to help my group of research to improve our interpretation stage. All right. The result line number 2 still same. We have the potential of silica rock. Instead of that, we still have low resistivity anomaly, which is maybe the fractured system already take over the area, and then maybe reflect to the resistivity value from 0 to 2000 ohm meter. Beside that, we have changeability result to be relate with the resistivity part. And then this 800 meter result, the potential of silica rock still can be observed. And then we believe one more set of fractured system is here, can be separate the whole of body for this silica rock. And then for conclusion, we believe when we integrate gravity and resistivity result, and then hopefully for future maybe we can integrate together with IP, so we can understand the volume of silica body, which is we will present after we have drilling result very soon. Okay, but of course this technique hopefully can give some sort of very fast data for everyone, especially geologists and geophysicists. But from that we can deliver to our stakeholders or mining engineer to design, to calculate their reserve and some sort of economic value for this area. And we also plan for our future work. We try to establish the conceptual model based on gravity value that we observe. We try to establish the model based on our site observation, gravity response, and then resistivity and IP result. Hopefully we will get a more clear picture about the silica rock occurrence in lodging area. Okay, so if you have any question and answer, we meet in that session. And like I mentioned, if you have any suggestion, especially on IP part, you can email to me, hariri@ukm.edu.my. In this slide, we also like to appreciate to our EAGE, especially NSGE 2021 committee members that accept our abstract and give opportunity to present today. And then beside that also, we like to acknowledge to GMG, Mineral and Geoscience Department, which allow us to present this their project actually. And then for geotechnology resources, staff that help us to record the data at the site. Thank you everyone. Last but not least, we like to attract your attention. Maybe you like to refer to our previous publication in Data in Brief. We have two publications there, number 1 and number 2. Maybe you like to refer it. And then Joseph, yep, everyone maybe like to refer this reference, especially when you like to use Oasis montage to process the gravity data. Thank you everyone. Thank you EAGE. Thank you for all the committee that involved for this conference. Thank you again. Bye bye.